Hi class, this is Gigi from Kauai Community College. In this video, we are finding the area formed by the curve f of x. In this case, that's the blue graph right there. F of x equals to 4x minus x squared, an upside down parabola. And we're looking at the area formed by that and the x-axis. Okay, and we are looking at the interval from -1 right here to 3 right here. So as you can see, the area form is part A and area B. Okay, so then the area that we are looking for is going to be A plus B. Now, what is the difference? The area that we are looking for is A plus B. Area A plus area B. What's the difference between that and the previous problem, which is the integral from -1 to 3? What's the difference? The integral is the net area. Okay, that means if you can look at, you can see right here, area A, region A, is below the x-axis. So when we take the integral from -1 to 0, the answer is going to be negative, right? And then in region B is above the x-axis. So when you take the integral from 0 to 3, the answer is positive. So we would say that the integral from -1 to 3, in terms of a value, it is going to be B minus A, right? Whereas we really want the area, so we really have to say, okay, well, I need to add them instead of subtracting them, taking the difference. So then how do we address the fact that the area is positive where the integral is negative for this A region that is below the x-axis? Okay, so how do we deal with that? If we write the integral from -1 to 0 of 4x minus x squared dx, we know visually that the answer here is going to be negative. Okay, but we don't want the negative value because we're actually talking about the area, and the area is a positive value. So we can deal with this a couple of ways. One is to go ahead and take the integral as is, and then take the absolute value to say that my area is a positive number. Okay, and that is part A plus then the integral plus the integral from 0 to 3 of 4x minus x squared dx. And that we don't need the absolute value because it's above the x-axis, and we know the integral, the accumulation of these little rectangles that we are drawing when you're taking the integral, those rectangles values are positive above the x-axis. So that's positive. We don't need to deal with the absolute value. Now, so that is, I said, one way to deal with the fact that this is negative. So the absolute value of a negative number is going to be positive, right? Another way we could deal with this is we would rewrite the integral. Instead of writing from -1 to 0, we could write then from 0 to -1. Okay, and that is because we have a property that said the integral from a to b of f of x dx is going to equal to the opposite of the integral from b to a f of x dx. So that is one property of integral that we know. Okay, so keep it the same and then make sure you take the absolute value or switch the index. Okay, switch the limits. So those are two ways of dealing, and this is 0 to 3 of 4x minus x squared dx. Okay. All right, so either case, you will get the same answer. Okay, so let's take the antiderivative. The fundamental calculus said the antiderivative evaluated from 0 to negative 1 plus the antiderivative evaluated from 0 to 3. Okay, so antiderivative of 4x is 2x squared minus antiderivative of x squared is x to the third divided by 3. Same here. Okay, so when we do upper minus lower, we will have 2 times negative 1 squared minus negative 1 to the third over 3 minus, when you plug in 0, we'll have 0 there, plus upper 2 times 3 squared minus 3 to the third over 3 minus lower, plug in 0, we'll have 0. So here, negative 1 squared is positive. That would be 2. Negative 1 to the third power is negative, times a negative is a positive, plus a third. And plus here, 3 squared is 9, times 2 is 18, minus 3 to the third, 27, divided by 3 is 9. So that really is 2 and a third, plus 9, which is 11 and a third. So that is the area. Okay, and if you remember or have seen the previous video, you will see that the integral from negative 1 to 3 really is 9 minus 2 and a third, and the answer to that was 6 and 2/3. That's the value for the integral, because part of it is negative, part of it is positive. The integral is the net area, which the negative will actually cancel out some of the positive, so you'll get a smaller value. Whereas when we're looking at the area formed by the curve and the x-axis, that negative value actually needs to be dealt with by taking the absolute value, or to switch the limits so that the area of a shape can be denoted as a positive number. So that's the difference. The integral is 6 and 2/3, whereas the area formed by the curve and the x-axis is 11 and 1/3.